Hey everybody, I'm going to do lab number 1 for you today. I've got all the supplies that I need. I've got my 3 chemicals over here. I got acetone, hexane, and water. I've got my 4 Sharpies. Actually, it's 2 Sharpies and 2 water-soluble markers. We'll call them Vis-a-Vis. I've got my 3 beakers. I've got my pieces of wire, and I also have my pieces of my strips of paper. Now, I don't have a watch glass cover that's goes over these 400 milliliter beakers, so instead of a watch glass cover, I'm going to use this piece of tin foil to cover up my hexane. So the first thing I'm going to do is, on procedure step number 2, I'm going to use a pencil to draw a line across the bottom, about 2 to 3 centimeters from the bottom. So here I go. I showed you on the intro video that line is really important because that's where I'm going to put my inks. When it comes to my different analates, I'm going to put my Sharpie or my water-soluble marker right there. Next thing I'm going to do is I'm going to label all my strips letters A through L. Now that I've separated my strips into 3 sets, I've got A, B, C, and D in one set, E, F, G, H in the next set, and I, J, K, L in the third set. Now, I'm going to use these for water, I'm going to use these for acetone, and I'm going to use these for hexane. So what I have to do is actually mark the 4 different analates on the 4 different strips for all 3 sets. I want to make sure that I keep everything straight and label everything. Before I begin, I want to make a data table. So I made a data table, and it marks which strip is going to have a black Sharpie, a green Sharpie, a black water-soluble, and a green water-soluble. BS for black Sharpie, GS for green Sharpie, BW for black water-soluble, and GW for green water-soluble. So now I'm going to mark according to my plan. Next thing I'm going to do is I'm going to skewer my set of 4 different pieces of paper on one skewer so that they can all fit inside of one beaker. I'm going to put A through D once again in the water. I'm going to put E through H in the acetone, and finally I through L in the hexane. But I have to make sure, as I mentioned in the first video, that when I skewer them, that the pieces of paper are just off the bottom. And so this might take a little messing around, but I should be able to get all 4. I'm trying to flatten them out, but because they're kind of curved, that'll make sure that they sit nicely next to each other. Now again, I want to make sure that they're not touching one another when they're in the beaker, so that the inks don't run from one paper onto the other, because that's going to give me bad results. So it takes a little bit of adjusting. But I think I got it. I think it's time to add the water and begin the experiment, at least in this beaker. I think I'm just going to do 2 at a time, because I'm having trouble keeping them from touching one another. The water makes them want to stick together. Even now they're trying to stick together. I think I got it. Let's set that off to the side and let the water creep its way up the paper. Next, I'm going to do the same for the acetone. I was able to secure a couple more pieces of wire, so let's get back to the skewering. I think I got it. So now I'm going to add the acetone. Better put on my goggles. Finally, the hexane. As I mentioned in the first video, the hexane is the most finicky of the 3 liquids that we're going to be using today because it's so volatile that it'll evaporate off the paper as it creeps up the paper through capillary action. And so I'm going to need to use this foil in order to cover it and hopefully keep the evaporation from happening. Now, because I'm going to be putting a cover over this, I like to fold down the tops of my pieces of paper because then it'll lay more nicely over the top. I think that'll work just great. Now let's add the hexane in. Cover it up. Double check that they're all touching the liquid, because if they're not touching the liquid, then they're not going to creep up. I think I need to add a little bit more liquid because one of these isn't touching the surface of the liquid. See if I can do this carefully by running it down the edge. There you go. All right, this one's going to be particularly slow, so it'll take a while to get it. But we'll be back after the experiment's finished. So the next thing I'm going to do is I'm going to start taking the ones that I started with out of the water and marking using a straight edge how far the dye traveled and how far the solvent traveled. And I'm going to write it down in my data table. So I've got my beaker for water right here, and I'm going to pull out the first two. Now, A and B were the Sharpie, and I'm going to mark with the straight edge how far the dye and how far the liquid water traveled, and write that down in my data table. So here are the first two. Actually, I'm just going to mark the lines first, and then I'm going to come back and measure them second. So take this one down. I'm going to pour out the water. I'm going to put them back on their pieces, and I'm going to let them hang so they can dry out a little bit. Next, I'll do the acetones. But it looks like they're still going, so I might give it a few more minutes. So it looks like both the hexane and the acetone have stopped. So I'm going to quickly mark the top of the solvent line so that I can do my analysis here in a little bit. Now you got to do the hexane right away because it begins evaporating immediately. So you got to grab them and put your lines down. You're going to lose them. Now my experiment's done. All that's left is to take some measurements, put it in my data table, and it's up to you then to analyze the results. Here you're looking at the 4 strips that were in the water beaker. As you can see, the first 2 were the permanent marker, and the last 2 were the water-soluble marker. In strip A, the analate barely moved off the line. I actually would say that it didn't move off the line at all. In the second one, it moved off slightly. Now once you get to the C and D strips, you'll notice that the analate moves significantly with the water. And you can see actually the colors separating as well. You've got the black one in letter C, and you can see that it's really a mixture of all different types of colors. And in the D strip, you'll notice that there's also a blue and yellow, which as you know make green. And you see a slight other color in there to add different tints to it. But for the most part, those color separations are what you would expect when you would separate the dyes of an ink. In this next set, these were the 4 that were in the acetone, and you can see that the acetone affected all 4 different markers. It's also worth noting that you can once again see the different mixes of inks that went in to making these black and green markers. So that was pretty cool to see. And finally, you're looking at the last 4 strips that were in the hexane. And as you can see, and it's a little bit difficult to see, but the hexane affected the first 2 strips, but not the last 2 strips as much. I'll give you a closer look here at my data table. You're looking at my data table, and the BS once again means black Sharpie, the GS means green Sharpie, BW for black water soluble, and GW for green water soluble. and you'll see the measurements that I took on all the strips. Remember, these numbers are all in centimeters. I'm going to leave this data with you. I want you now to do the required calculations and answer the analysis questions and have your write-up in by the due date. Anyway, thanks for watching.